Howdy, this is Mr. Potter. We're going to go over the 2017 AP Computer Science A free response questions today. The questions were very similar to what we've talked about in our previous analysis of free response questions, so I felt this was a pretty good representation of the type of questions we were expecting. So let's take a look at question number 1. So it says, this question involves identifying and processing the digits of a non-negative integer. The declaration of the digits class is shown below. You will write the constructor and one method of the digits class. So I'm looking at public class digits. It says the list of digits from the number used to construct this object. The digits appear in the list in the same order in which they appear in the original number. And notice we have a private array list of integers called digit list. So this is going to hold all of our data. And in part A, we're going to have to create a constructor called digits. The idea here is that we're going to be passed some number, and we're going to try and figure out how to extract the digits of this number and put them as integer elements in this array list. Then we're going to have to implement a function called isStrictlyIncreasing, and this method is going to either give us a true or false depending on if the digits are increasing or if they're not. So looking at part A, this is our constructor. So if I'm given a 5-digit number like 15704, then what's going to happen is this first number is going to show up and be put in that first spot. The second number is going to be put in the second spot, and so forth, and so forth, and so forth. So what we're going to need to do is find some way to peel off these numbers one at a time. And I have a feeling some fancy dividing by 10 and modulus by 10 is going to give us our answer. The key thing is that these are going to, each one of these elements represents a single digit, which is why I'm dividing by 10 or using mod 10. And the other thing we have to watch out for is that if we're given a 0, keep in mind that we might have to watch our loop that we're going to be looping through this number to make sure that we take care of 0 as a special case. So, looking at this, I've got my public digits int num. This is my constructor, and the first thing I have to do is I have to create that digit list. So I've got this variable called digit list, and this is going to have to be a new array list of template integers. So I have to create a digit list object that we're going to be manipulating here. And then what I need to do now is to go through this number one digit at a time. So I'm going to say while num is greater than 0. And I'm going to do stuff in here, but then I'm also going to have to take care of this at the end. And I'm going to have to say something like if the digit list dot size is equal to 0. In other words, if 0 was the argument, then what I want to do is I want to take digit list and just add an integer object. So I want to create a, I want to create a new integer object here. Let's get rid of that. So I want a new integer object containing a 0. So I've got this where I'm creating a new integer object. Now there is something in Java called autoboxing. And what that means is that if I wanted to be fancy, I could have just said digit.add and just put a 0 in there. And Java is savvy enough, especially Java 1.7 and later, is savvy enough to know that if I just put a 0 in here, it really should create a integer object. And so what the Java automatically does is it automatically does this for me. But if I don't think about it, then I can actually physically create an integer object, or I can just put an int in there, and Java treats it the correct way either way. So now I need to go through this. What I need to do is I need to get the values in here. So I'm going to create a variable called quotient, and this is going to be equal to num divided by 10. and I'm going to do an int remainder, and this is going to be num mod 10. And so the idea here is that I want to insert these objects into the list in the appropriate way. So if I had a number like 15704, so let's say I have 15704. If I divide by 10, I'm going to get this as my quotient. So this is quotient. And this right here is my remainder. So remainder is actually going to be the last digit that I have, and I want to insert everything that comes from quotient before that element. So what I want to do is I actually want to insert this into the list. So I'm going to do digit list dot add, and I want to add my remainder, but I want to add it into position 0. Remember that ArrayList has this ability to add stuff in a particular spot. So what's happening is the very first time I go through this, I've got an array list with a 4 in it. The next time I go through this, my array list had a 4 in it, but the 0 got inserted before it. And then I have the 0 and I have the 4, but this 7 gets inserted before this. I'm always inserting in position 0, and as I insert, the rest of these numbers kind of get pushed down into the array. So num is greater than 0. I've got this int quote gets num divided by 10 and remainder is num mod 10, but I really can kind of cheat here, and instead of just doing int quote, I can just say num. But then if I do that, I need to make sure I take care of this remainder beforehand. So let's go ahead and clean this up just a little bit more. I want the remainder, so I'm going to say int remainder is going to be num modulus 10, and then down here is going to be my iteration for my loop. My num is going to get num divided by 10. So here's my test, and here's my iteration of this. My initialization actually takes care of in the constructor. Now, autoboxing works real well, so I don't have to create a new integer called remainder. I don't have to put this in here. I can just put rem like we did down here in the bottom. I can use this autoboxing to my advantage. So that's part A. On part B, we're saying, okay, now that we know our constructor works, I want to make sure that I have a method called isStrictlyIncreasing. And this method should return a true if the elements are in strictly increasing order, otherwise it returns a false. So notice that 1, 3, 5, 6, these numbers are increasing order. 3 is bigger than 1, 5 is bigger than 3, 6 is bigger than 5. Notice here I have a pair of digits that are repeated. In other words, this is going to have to be a greater than, not a greater than or equal to relationship. So I get a false in that situation. And of course, if the digits are in the wrong order, I'm also going to get a false. And if instead of being strictly increasing, I'm strictly decreasing, I'm also going to get a false. But one other thing I'm going to have to be careful of is the situation where I only have one digit in my expression. And if I only have one digit, then it by definition is going to be true. So we're going to have to compensate for that in our code. So looking at this, so I want to write this method. I'm going to be returning a variable. Now keep in mind, whenever I'm returning a variable, the very first thing that I want to do is make sure that I declare that variable. So I'm going to declare Boolean called result. And then I want to go through the digits in my list, and I want to check them in order. So I'm going to have to keep track of the previous value, and I'm going to assign it some number. We're going to talk about what that is in just a moment. But I want to go through my list. So I'm going to have int val in digit list. And keep in mind, I'm using that same auto boxing here. This is just called auto unboxing when I'm doing this. Of course, I could have these be integer objects. I just have to make sure that I get the value of that integer object later on. But using them as ints makes this a lot easier to work with. So if my val ends up being bad, in other words, if the digit that I'm getting is less than or equal to whatever my previous value is, then what I want to do at that point is I want to go ahead and return false. Because at that point, if this happens, I've gone through and I've hit a snag. I've had a 1, then I've got a 3, then I've got a 5, then this digit here is less than or equal to whatever my previous value was. And as soon as I hit that digit, I know that this result is going to be false because it's messed up. Now, I'm going to have to, I talked about this just a moment ago, and I'm going to need to make sure that I change that value. So I'm going to have to say something like prevval gets val. In other words, once I've checked to see is 3 bigger than 1, now 3 is the new check val. And then I'm checking is 5 bigger than 3, and now 5 is my new check val. And then I'm checking to see if this digit here is bigger than 5, and that was the snafu. That's the one that messed us up. Now, if I make it through this successfully, then if I've made it through this loop completely, then I know that my number is good, and I can just return true. What that really means is that I don't need this variable here. Of course, I can declare it. I could go ahead and assign it, but then just go ahead and return it at the end. So the last thing I want to talk about is, what is this mystery value here? Well, I want to go back to what we talked about before. If I have a single digit, I need to make sure that it'll work. But we also remember from our constructor, we could have a single digit that's 0. So I need to make sure that I can get a value that is less than 0, which means I want this previous value to be -1. And any negative number will do as long as it's less than 0. Because I want to make sure that if val is 0, that I get through this adequately. In other words, this doesn't trigger. So if the only thing I had was a 0, I want to make sure that I'm never going to trigger this. So here I'd see if 0 is less than or equal to -1, and I'm not going to go into this if statement. I'm not going to return false. I can go ahead and assign previous value to 0, but I'm never going to use it again because I leave this for loop. So that's problem 1. So now in problem 2, this question involves the design of a class that will be used to produce practice problems. The following study practice interface represents practice problems that can be used to study some subject. So because I'm going to have to implement some type of interface here, I'm going to need to make sure that I write a getProblem method that returns a string, and I'm going to need to write a nextProblem method that is void. In other words, just changes the function. This is some type of mutator or modifier. So when I create an object, MultPractice 7, 3, this 7 and this 3 are important for me to keep track of. I'm going to have a first number and a second number so that whenever I call on this getProblem method, it's going to say that whatever my first number is times the second number. So notice it's 7 times 3, 7 times 4, 7 times 5. And I notice that whenever this getProblem is done, it's going to give me the first integer times the second integer, but this next problem is going to give me the next problem. It's going to update the state, and looking at it, it looks like this 3 becomes a 4, and the 4 becomes a 5, so it looks like this is being plus plus. It looks like it's being incremented. So this is giving me an idea of how I'm going to have to write this class. Keep in mind that writing a class is one of the main ideas that the AP is testing. So I'm giving it an object with the first number 4 and the second number 12. So the first thing I do is I go to next problem. Remember, next problem is going to increment that 12. That 12 is now a 13. And that's why a 13 shows up here. Then if I tell it to get that problem again, that 13 is going to show up again. But then I do next problem, which plus pluses, so now it's a 14. And then I do next problem, which plus pluses, makes it a 15. Notice that I never asked it to get the problem, so I never see the 4 times 14 problem over here. All I see is when I call on getProblem after I've done this twice, after I plus twice, and now I've got a 15, I see the 4 times 15. And then I call on next problem one last time, I get the problem one last time, and I've incremented that 15 to a 16. So this gives me the idea of where I want to go here. So I have to write the class. Keep in mind that I'm going to have to keep track of whatever the first number is, I'm going to have to keep in mind that I'm going to have to keep track of whatever the first number is and whatever the second number is. So that's what I'm going to have to do. So first thing I'm going to do is I'm going to say public class, and this is MultPractice, implements study practice. Remember that when I'm trying to use an interface here, I want to implement. So now I need to make sure that I have my first number and my second number. These are the values that are going to be kept track of when I'm printing a problem or when I'm incrementing to the next problem. So I'm going to have a private int. I'm going to call this first and second. And then I'm going to have my constructor. So public MultPractice. And remember that my MultPractice constructor had 2 parameters. So I'm going to call this num1 and num2. And the whole idea behind this constructor is that it's going to populate first and second with whatever values I have here in num1 and num2. So I'm going to say that first is going to get num1 and second is going to get num2. So that's my constructor. Now the other thing I have to remember is because this is an interface, I need to make sure that I implement getProblem and nextProblem. I need to write the code for that. So first thing I'm going to do is write the code for getProblem. So public string getProblem. And keep in mind, because it's returning a string, I need to make sure that I'm returning a string. So I'm going to concatenate my first number plus the string times plus whatever my second number is. And that's the extent of getProblem. All of it's doing is returning a string. Keep in mind, don't use system.out.println here. You won't get the full credit for it. It's a method that returns a string. You need to make sure that you return a string. The last thing that I need to do is I need to take care of this next problem. In other words, I need to figure out what the next problem is. And keep in mind, the next problem is going to increment whatever second is. So I'm going to have public. This is a void, and I'm going to call this next problem. And the whole idea here is I'm going to take whatever second is, and I'm going to plus it. And that's all it is. So this is going to be second plus. So that's problem 2. Looking at this, I would say that you're looking at a point for this method header and a point for its contents, a point for this method header and a point for its contents, of course needing return here, not system.out.println. A point for the constructor, a point for making sure that you're passing it the 2 parameters, and a point for assigning the parameters correctly. Probably looking at a point for declaring your private instance variables, and a point for your class constructor, which includes this implementing the interface. That's very important. So, on to problem 3. All right, for question 3, it says the question involves analyzing and modifying a string. The following phrase class maintains a phrase in an instance variable and has methods that access and make changes to the phrase. You'll write 2 methods of the phrase class. So I'm looking at this, and the things that I'm noticing is that I keep track of current phrase. I've got a constructor, which is okay, it's already written. I've got a method called findNthOccurrence. Given a string and the integer n, it's going to find out the nth occurrence of something. And if it doesn't show up after the nth time, then I'm going to get a -1 out of it. Then I've got this replaceNthOccurrence, which takes a string and replaces all instances of a string with a particular replacement string. And we're going to have to write that code. And then it's got a method called findLastOccurrence, and we're going to have to write that code as well. So, looking at what we've got here, here are some examples. So I have the phrase, a cat ate late, and we can return at with rain, but we're only replacing the first occurrence. So here's the first time at shows up, and we're replacing it with rain, and that's where we get crane from. Notice that the at over here is actually the second occurrence, so it doesn't change, it's still at over here. Then if I replace the sixth occurrence of at, well, there's an at, and there's an at, and there's another at. There is no sixth occurrence. There are 3 occurrences here, so nothing's going to change. And same thing's going to happen if I try and everywhere I see a bat, it's not going to replace it. So I get the exact same string as well. So let's say I have AAAA and I replace the first occurrence of AAAA with XX. Well, that's going to give us XXAA. Here I've got AAAA and the second occurrence, well, this is the first occurrence, the first AA. Then the second occurrence is going to be the second A along with the third A. And that's what actually gets replaced with the BBB. So keep in mind that first thing I notice is that it only changes once. Nothing else is going to change. So here it only changed once, here it only changed once. Nothing else is going to change. And if the string doesn't appear or if this number is out of bounds, there's not going to be any change. So those are the 2 things I have to watch out for with this idea of replace nth occurrence. So notice that they tell us that we have this method called find the nth occurrence, and now I just want to replace the nth occurrence. So I can assume that this works correctly, and I must use it to receive full credit. So what I need to do is I have to go through and find out first if this value is -1, nothing's going to happen. But if this value isn't -1, then I'm going to have to make a change. So looking at this, I'm going to go ahead and say int spot is going to get the result of find nth occurrence. At that particular string for that particular value of n. And if spot is equal to -1, then we're going to return. Notice I can just do a plain return because this is a void method. Now if I get past this return, then that means spot is not -1, and that means that this string shows up somewhere in current string, so I need to replace it. So I need to go everywhere up to spot, and then from this point on, wherever str would normally end, I want to replace that on, and I want to replace str with REPL. So I'm going to say that current string is going to get, and I'm going to piece this together. Notice it starts at position 0 and goes on to whatever position spot is. So this is going to be using substring. So it's going to be current string dot substring, starting at 0 and going to spot. And I'm going to concatenate that with the string that I want to replace. I want to replace it with REPL. And I want to continue concatenating with the rest of the word, but this if this was spot, then this is going to be spot plus whatever the length of string is. So I'm going to be doing current string dot substring with spot plus str dot length. And remember that substring has two options. It has the 2 parameter, which gives us a starting point and ending point, but it also has the 1 parameter version, in which case it just gives us from that point until the end of the word, and that's really what we want. So I'm going to have everything from position 0 to position spot unchanged. And then from spot to whatever str plus length, spot plus that str length, that's going to be replaced with REPL. And then from this, which is spot plus whatever str dot length, from this point on until the end of the word is going to stay the same. And then I'm done. So we're going to go ahead and return. So very straightforward what we're doing here. We're just replacing the nth occurrence, but we have to find the nth occurrence first. We assume that it works, and if we don't use it, then we're not going to receive full credit. And that's because string has methods that work very similar to this already, but they're not part of the AP subset. They're not part of the AP code, the code that the advanced placement exam expects us to know for Java, for the AP. So they're expecting us to use the methods that have been written in our class. So in other words, we're going to have to use this find nth occurrence even though we have no idea how it's used. Alright, so the second part of this is that we have to write the phrase method findLastOccurrence. So if I'm looking for the last occurrence, it's going to tell me the last time that something happened. So if I'm looking for the last occurrence of AT, well, there's an AT and there's an AT and there's an AT, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That A is at position 11. But if I'm looking for the last occurrence of CAT, that only happens here, and that's 0, 1, 2. That's where we get the 2 from. But the word bat doesn't show up anywhere in this string, so that's where we're getting the -1 from. Now, what's probably going to be the easiest thing for us to do is to just loop through and let this idea of find nth occurrence. If I use find nth occurrence and let it start at 0 and then 1 and then 2 and then 3 and so forth, and as soon as I get some value that gives me a -1, I say, aha! It must have been the previous value that we were looking for. So that's the idea behind what we're going to write. Now, they tell us that we must use this in order to receive full credit, and that's because string has a last index of. And of course, it would be real easy just to say, oh, last index of whatever str is. And that's not going to give us full credit because they want to see if we can implement this method along with some semblance of logic. So what I'm going to do is I'm going to say int occur equals 1. So I'm going to look first in the first spot and see, okay, if I write find nth occurrence for the first spot and get a -1, then I'm going to have a problem. Otherwise, I'm going to need to keep going through here. So I'm going to start this at 0 because I'm going to use a while loop. So while find nth occurrence of str and occur, while that value for the next instance is greater than -1, then I'm going to occur plus plus. So let me talk about what's happening here. I'm starting off at 0, but then I'm seeing where's the first time that str,1 shows up. And if it doesn't work, then occur is going to stay 0 and then I know that I'm going to have run into a problem. But as I go through this and say, okay, fine, if this is a 1, search the second spot. If this is a 2, search the third spot. Whenever I break out of this loop, occur is going to be the last time that we found it. So if occur is equal to 0, which means that this loop never got triggered because str never even showed up in the word. If that happens, then we're going to go ahead and return -1. Otherwise, the last time we found it was when occur was at a particular value, so I'm going to want to return the findNthOccurrence for str and occur. So in other words, if there were 3 occurrences of it, then that means when I was looking for the 4th occurrence of it, I failed. I got a false. So occur was still 3. It's not 0. I know it shows up 3 times in here. The last time is the 3rd time, and so that's what I want to return. So that's my code for this findNthOccurrence. And again, they're asking you to use findNthOccurrence here because it would be so easy to just say, oh, what's the last index of? And it would find it. But that's not what they're testing here. And on to question 4. So on question 4, I've got this 2-dimensional array, and keep in mind that traversing 2-dimensional arrays is one of the big concepts we like to see on the free response questions. So I've got these integers inside this 2-dimensional array, and I've got this idea of a position class. So this position class is going to be a particular position at a particular row and a particular column. So we're going to have to iterate through this array and do something with it, dealing with a position object. So we're either going to be creating position objects or referring to position objects. So I'm going to have some function called findPosition. And the idea behind this findPosition is I'm going to have to go through the array and return a position object, whatever the position is of this number inside my array. Now, one of the things that you'll notice here is that none of these numbers repeat. And although it's not explicitly stated that all of these numbers are going to repeat, they do say that they are successors. So we're looking at things that follow one after the other. So I'm really looking at things that won't repeat. So we just need to find the first occurrence. So what I need to do is I need to go through this array, row by row, column by column, searching for num. And if I find it, then I want to create a position object. If I don't find it, if it's not in my array, then I'm going to return a null. So I'm going to have to go through this row by row. So I'm going to say for int r gets 0, r is less than int r dot length r plus plus. That's going to go row by row, and then I want to go column by column. So for int c gets 0, c is less than int r sub 0, because I want to know the length of that row, c plus plus. And then what I'm going to do in here is I'm going to say if the number is in that particular row and column for int r. So if num is equal to int r sub c, then I want to make sure that I return a position object. So I'm going to return a new position. And keep in mind that the position constructor uses the row and the column. So I'm going to pass r comma c as parameters to this position class. So if I go through this loop and at any point my num matches one of the elements in my int array, I'm going to create a new position object for that row and that column, and I'm going to return it. But if I get through all of this, I still have to return something. And the provision is, if I go through everything and I don't find it, if I never hit this equals equals, then I want to go ahead and return null. So that's part A. On part B, now what we need to do is we need to write a static method called getSuccessorArray. And what this is going to do is we're going to be creating a two-dimensional array, but notice that these are arrays of positions. So I'm going to have to create a position object for each one of these elements in the array. And in order to do this, I'm going to use the function that we just wrote. Notice that it says assume that findPosition works as specified. Remember that findPosition, if I do findPosition of a num, that's going to give me a position object with a particular row and column where it's found. What's different though is I'm looking for the successors. So what comes after a 5? Well, a 6 does. And a 6 is located in row 1, column 3. So notice that here I get a row 1 and a column 3. What comes after 6? Well, a 7 does. And the position of 7 is in the second row in the third column. So this is a second row, third column. And of course the problem is if I have a 16 here, the successor of 16 is 17, which doesn't show up anywhere in here. And so that means that I get a null in that particular spot. So what I'm going to want to do is I want to go row by row, column by column, and I'm going to find the element that's there. I'm going to look for its successor and find the position of its successor in the array, and that's what actually gets created in this spot. So that's what we're going to have to write. Keep in mind I'm trying to return a position two-dimensional array, so I want to create a position two-dimensional array. So I'm going to say position two-dimensional array. I'm going to go ahead and call this pos, and this is going to be a new position with the rows equal to whatever the length of this int array is. And the columns equal to whatever the length of one row is. So int r sub 0 dot length. And I'm going to create that. And now what I want to do is I want to go through this original matrix, the matrix of integers. This is our int r. I want to go through this, and I'm going to say for int r gets 0, r is less than int r dot length r plus plus, and then for int c gets 0, c is less than int r dot sub 0 dot length c plus plus, and I'm going to go through this, and I need to get the position. So int num is going to be whatever is at that particular spot, int r for that row and that column. In other words, for me, num is going to be the 5. And then I'm going to look for whatever comes next. So I'm going to look for whatever the successor is of num plus 1, in other words. And I'm going to say that pos at position r, c is going to be equal to whatever findPosition gives me. Remember that I assume this method works. And I'm looking for num plus plus, or num plus 1, in int array. And that's going to fill that spot. That's going to go over to this array and say, oh, 6 is in the second row, the first row, third column, so 1, 3 gets put into this spot. The successor to 6 is 7, which is in the second row, third column, so that's what gets put in that spot. And this table gets filled up by all of these positions. And then of course the thing I have to remember is that I've created this position object. Now I need to return pause. So this exam was pretty much what I expected. I think it's a lot easier, or at least a lot shorter, than the 2016 exam. Notice that we had the string manipulation in problem 3. We had the two-dimensional array manipulation in problem 4. We had writing our own class in problem 2. And then of course problem 1 had us dealing with just working with objects in an array list. Pretty much what we expect to see on a free response. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.